We've all heard that the human brain is one of the most complicated objects in the universe, and with good reason. When we think, which is all the time, the neurons in our brain make connections with one another. These connections are called synapses, and we create countless every day. Say you're studying for a test. After learning the information which creates neurons and synapses, you'll probably make a Quizlet and use it to reaffirm concepts you already know. This process strengthens your synapses. The synapses act as a pathway for your neurons to transmit information, hence the word neurotransmitter. All of this is just human biology, but when we synthesize neural networks, we step into the realm of computational physics. There are three main parts to an artificial neural network: the input, the output, and the hidden layers. This is the part of the process that you'll never see, but it happens in mere seconds. To understand it, let's play the classic road trip game, 20 questions. So the input for this game is whatever I'm thinking of, and the outputs are the guesses you'll make. In this case, the hidden layers are the questions you'll ask, and the yeses or nos I give will act as the activation functions, which encourage you to ask the next question. The first question you ask has the most weight. Is it living? Yes, it is. Okay, so now you'll ask, is it a human? Because that has become more important than a question like, is it in a kitchen? I say yes again, and you continue to ask questions you think have a bigger influence on your guess, while ruling out other questions that you think don't have as much weight. Every time I say yes or no, it strengthens your connections and your confidence in your final answer. Eventually, you've asked me a few questions and you think you have a guess. Percy Jackson, you shout confidently. Unfortunately, you're wrong, because I was thinking of Artemis Fowl, and even if I wasn't, your questions weren't specific enough. There are hundreds of fictional boys with dark hair, and you haven't been trained to know them all. It's okay though, we'll keep playing until you get better at guessing properly. In order to train you, every time you guess wrong, I punch you, and every time you're right, you get an ice cream. After days and weeks and months of playing 20 questions, you're bruised and have severe brain freeze, but you finally got the hang of it. You can quickly figure out important specific questions and narrow down your answers until your guess with the highest probability of being correct is the right one. Now take this entire scenario, add 10 times the inputs, hidden layers, outputs, testing, and training, scrub the process up until it happens in milliseconds, replace the punches and ice cream for a mathematical system, and you're looking at the brain of an AI computer. What good is all of this, you ask? Well, for just 3 examples, IBM supercomputer Watson predicts the weather for you, and neural networks allow you to use just your face to sign into your phone. They also let Google's Quick Draw figure out what your half-baked scribbles are. Now that you know what neural networks are, I hope you can find them in the world around you and also look for places where we can use them in the future. Just recently, physicists and programmers came together to figure out how to make neural networks better understand 3D and curved objects. As the next generation, we should focus on how we can use a computer's cognitive abilities to make our world a better place, because the possibilities are endless. Thank you for watching.